$405, and Libby.
$410.
$410. There are the four bids. The actual retail price is...
The ground starts to quiver. Telltale signs of what could be a devastating. Don't produce greenhouse gas emissions, we might still be able to prevent some of the worst effects of climate change.
For years, the use of concrete has been a practice for all of us. It has been utilized for roads, houses, bridges, buildings, and other structures. However, producing a single piece of concrete like this creates many effects in our environment. Many of us are aware of the concrete's basic four components: sand, gravel, cement, and of course, water. This conventional concrete composition poses harm to our environment. Look at those pieces of concrete taken away from this area. After it serves its purpose, it will be taken away and end up in landfills. Imagine the carbon footprint when sand, gravel, and cement were extracted and processed from rivers and plants. And after it ends up in landfills, imagine the ecotoxicity contribution due to the leaches of its constituents. Production of another batch of concrete will generate more carbon footprint and other environmental impacts. But it doesn't have to be that way now. We believe that concrete has the potential to become a part of circular economy. These pieces of concrete can still be used as aggregates to produce new concrete. This lessens the carbon footprint of concrete and will also reduce fossil fuel depletion, global warming effects, and other environmental impacts.
The team centralized the first discussion on locating possible suppliers of SCMs. Fly ash and slags are the prominent SCMs available in the country. However, slag imposes so much harm to our environment, hence the possibility of this for Ecoconcrete has been rolled out.
The composition of the base case scenario concrete comprises 83% of aggregates and 17% of Portland cement as binder, having the water-to-binder ratio of 0.40. This composition resulted in a service life of 11.9 years. However, this is relatively small compared to the potential environmental impact it imposes, considering that the aggregates consumed energy when it was transported from Cibobo, Calabanga to Ateneo de Naga University, which is approximately 23 kilometers. In addition, the cement supplier is relatively distant from the batching plant, which constitutes a lot of energy usage.
The alternative case scenario concrete, on the other hand, comprises 83% aggregate. This consists of around 47% of fine aggregate, 11% of natural coarse aggregate, and 42% of recycled coarse aggregate. The team also reached the maximum cement replacement percentage by substituting 40% of fly ash to Portland cement. Overall, the ACS concrete is comprised of around 39% of sand as fine aggregate, 8.8% of natural coarse aggregate, 35.2% of recycled coarse aggregate, 10.2% of conventional Portland cement, and 6.8% of fly ash as SCM with 0.40 water-to-binder ratio. This design mix results in a service life of 23.7 years and a single score of 31.07%. These scores only capitulate the durability performance of the proposed design mix, with the aim of maintaining the best equilibrium between the durability and environmental impact. The life cycle assessment bound to cradle-to-gate analysis have been utilized. The same suppliers of aggregate and cement were used for ACS, and for the supplier of fly ash, the team chose the nearest plant to the university, Santa Rosa, Laguna, with a distance 342 kilometers. The use of RCA also required electricity. Hence, the team converted the horsepower to kilowatts required in crushing concrete, and concluded that 1 kilogram of concrete required require 0.00829 kWh per kilogram.
The LCA analyzed the potential environmental impact reduction percentage using predefined values and user-defined transportation and electricity use values. The team has taken into good consideration that a durable concrete is not enough. Hence, the need for a concrete producing high average of potential environmental impact reduction is a must. This PEIR constitutes of global warming, carcinogenic, ozone layer depletion, ecotoxicity, and fossil fuel depletion.
For years, we, as civil engineers, have been on the front line of innovation and advancements.
But our passion for shaping the world comes with a price.
We have also made our way on the front lines of pollution.
The skyscrapers we've built and the bridges we've made impose harm to Earth.
Join us as we start revolutionizing for a sustainable civil engineering industry.
Together with KNKR2, let's not recreate the past.
Instead, design a better present for a sustainable future.
Hello, is this the CE Innovation channel? I'd like to sponsor KNKR2's cause.
KNKR2 for sustainable civil engineering industry, always advancing.